having disposed of the frivolities, I should like to formally welcome you to this tape. It is offered as a representative collection of most, if not nearly all, the tones and announcements you may encounter when using the telephone in Britain, and I humbly apologise now for any errors or omissions. Equally, you must forgive the poor quality of some of the recordings. This is mainly due to exigencies of recording in the field, and partly due to the large amount of induced hum present on the line where most of the recordings were made. Thanks must be now given to British Railways and the Post Office, without whose unwitting cooperation this tape could never else have been made. And finally, before we go into the tape, let me just remind you that it is not copyright. The proposal is that the first half of the tape should deal with ordinary tones commonly heard by the subscriber, such as dial tone, ringing tone, busy tone, and so on, then with a few tones not so commonly heard by the subscriber, and various engineering and other test facilities. The second half will deal with recorded announcements and various miscellaneous signals such as telemetry. Following all this, there will be a short mention of tones used on private automatic exchanges. Now, if we go into the tones, we should first note that there are three methods of commonly producing tones used in this country. By far the most normal is the ring machine, which, with some detailed differences, is used in most types of exchange. In the very recent electronic exchanges, transistorized tone generators are sometimes used, and in the older small rural exchanges and a wide variety of PAXs, that is private automatic exchanges with no connection to the outside system, vibrator relays produce the tones, which are timed by a chain of 3 interacting relays. We will now proceed with our investigation of the tones proper, and start with dial tone. This is a continuous tone informing the caller he may now dial, and it has been the standard practice to provide this tone since early times. As late as the 1920s, however, there was a school of thought that all tones were confusing to the caller, and that they should be dispensed with wherever possible. Thus, in the case of the all-relay exchanges and the Siemens Brothers VAX, Village Automatic Exchange, which was adopted as the Post Office UAX number 5, UAX being Unit Automatic Exchange, no dial tone was returned, since sufficient connecting circuits were provided to ensure no delay in finding a line. As a no tone does not make a very interesting recording, we'll press on to the sound of a vibrator tone that is produced by the relays. It generally has a very distinct clicking or rattling sound. A selection of the machine-produced dial tones now follows. On the older machines the frequency was specified at 33 Hz, and on the more recent ones 50 Hz. The difference is, however, slight. Apologies for the background noises on some of those, but that was unavoidable. Next we have a transistorized dial tone as used on the Ericsson Mini-Rax Rural Automatic Exchange as supplied to British Railways. There's rather a lot of unavoidable line noise on this recording that was induced from the traction power cables between London and Southampton. And following that, and to close this section, here's the very characteristic dial tone used on small PABXs connected to the system of the London Transport Executive. The tone is produced by a standard domestic doorbell chime. The exchange system of London Transport is also worthy of mention at this stage. It is a very large PAX system consisting of several interlinked exchanges extending over a distance of about 50 miles from end to end of the system, All work on a link numbering system, and the dials are all director dials with 3 letter codes for various services. It's nice to know that some people in London still are instructed to dial letters for their calls. We now move on to ringing tone, and in this description we must not forget the manual exchanges, since these also have to return ringing tone when they are reached over lines from automatic exchanges. As in other countries, ringing tone in Britain was originally a single burst of tone and ringing repeated periodically, but experience showed that a double burst of ringing sounded more urgent and secured a quicker reply from the called subscriber. The single burst was, however, easier to produce when relays were used to save the cost of a ringing machine. It has therefore survived on small exchanges. Examples follow of the Post Office UAX5 and a 200-line PAX, both of these tones being vibrator produced, and also the ringing tone on a large railway PAX using 50 Hz mains hum but timed by interacting relays. Those 2 recordings were the UAX5. Passing on to the conventional double beat ringing tone, we can again differentiate between vibrator, machine and electronically produced tones. When you're using vibrator ringing tones, on most exchanges a buzzer relay tuned to around 133 Hz is used, and here are 3 examples: Post Office UAX12, a manual exchange and another PAX. As you will probably have noticed in the first example, that one of the problems with these vibrating relays is that they very easily get out of adjustment, and the resulting tones can be quite ghastly. On very small exchanges, to save the cost of a separate ringing tone vibrator, interrupted dial tone is used. This is the practice on the Post Office PABX1, and the following example, which is a railway PABX at Bath. I answered too quickly there. When we come to examine machine ringing, we find a very wide range of examples, and a practiced ear can often determine the type of exchange equipment and even the actual exchange from the tone. The first generation of ringing motors produced a constant nominal 133 Hz, and these have a very distinctive sound. These examples are of machines from a manual exchange, a railway PABX, and a UAX7. In the last case, this type of machine seems to be only fitted to the UAX7, and therefore it's very characteristic.
Working out.
On the more modern machines, the 400 Hz continuous output is taken and modulated by the ringing current frequency, giving a warbling effect. Once again, various manufacturers of machines can be picked out, although of course the machine may have been a replacement in some cases. It's not so useful for identifying the exchange equipment. The first one here is a Siemens Brothers, the second is a recent Ericsson. The others aren't picked out individually here. Of special note is the ringing sequence of crossbar exchanges. When the number has been dialed, there is an immediate burst of ringing, followed by ringing in the conventional cadence. The absence of waiting for the first ring tends to reassure the subscriber, and has in fact been standard practice in Germany since the 1920s. It's a very welcome innovation here as well. Occasionally, various unwanted noises tend to filter into the ringing supply, as in the next two examples. In the first case, Waterloo 928 exchange, the ringing is feeding back into the machine, and in the second, which is Cambridge Special Faults, the buzzer tone operated by ringing this number appears to be feeding back down the line. A special oddity is the ringing tone on the fault reporting number at national and monarch exchanges. It is very high-pitched. Unfortunately, it had to be taped in rather a noisy place. Finally, here's an example of a transistorized ringing tone. The background noise is induction noise and is not part of the demonstration. Turning now to busy tone, we do not find so much variation. When it's produced by vibrators, it seldom sounds very healthy. As we've already mentioned, these often seem to go out of adjustment. Here are a couple of examples. Machine-produced tone naturally sounds different, although it is the same nominal 400 Hz. The precise frequency and timing vary, but the tone is always recognizable.